Okay, great. Hello, everybody. Welcome to our webinar. So just a quick little introduction of our two speakers. On Reconstruct side, we have Katie Heron. She's the CFO here at Reconstruct. And just a few fun facts about Katie is that she lives in Chicago. She went to the University of Michigan. And in her free time, she fosters rescue dogs. A little bit about Reconstruct and where Katie works. Reconstruct is a SaaS platform that brings together all forms of reality capture, and it produces a 2D and 3D reality map that your on-site and your off-site teams can both walk through together 24/7 whenever you want. You can also bring in drawings in BIM into your project schedules and view them all overlaid with reality so that you can fully understand what's there versus what should be there. Also today, we have Steve DeVito from Procon Consulting. Steve lives in Asheville, North Carolina. He rides motorcycles and he has 2 rabbits. So it's a little bit about Steve as well. And then Steve's going to walk through, who Procon is and then take us through the webinar.
Thank you, Summer. Procon Consulting is a owner advocate, owner representative construction management firm primarily. So we represent the owner's interests during design construction processes during the building life cycle and turnover to operations and maintenance. And we also implement solutions for the building life cycle in operations and maintenance and through the next cycle of repairs and alterations. So our construction management division, our program and project managers, owner advocates, our commissioning division is there to be able to make sure that the building energy management systems and BAS systems and air supply and other systems are working properly. My group implements technology solutions both for our own operations in other divisions and also for owners. So we implement BIM, digital twin, GIS type tools. And then we have a risk management division that does estimating and scheduling. So we were tasked with looking at a 60-year-old building. This is a large building in the GSA Denver Federal Center, primarily made of warehouse space where actually ice cores from the poles of the earth are stored by NOAA so that they can go back and look at the historical record using them. This is like a lot of older facilities where there were lack of understanding in terms of documented reality conditions on the site. And this is a problem with older buildings. It's even a problem with newer buildings in that the documentation has been changed over time, and the record keeping is not so fluid because there may have been different people taking care of different drawings at different times. So there was, a frankendrawing situation where the owner, GSA, and the architecture engineering firm who was going to be working on this prospectus level fire and life safety repair project did not know what the actual conditions were. So GSA was looking at different options. They can go and just do a laser scan, which is traditional, but the problem with that is that it's very costly and it's a very long process. You can spend a month in a building like this just scanning before you can then derive drawings from the scan. So we had to ask ourselves, is there something better that we can do for GSA that will meet their needs in a much lower cost and quicker turnaround in terms of time?
So that's where the Reconstruct solution came into play. Reconstruct allows our users to automatically generate a real 2D floor plan and a 3D reality map from a simple video. Once this video is uploaded into our platform, users can measure distances to a sub-inch level of accuracy. And teams can also collaborate within the system by dropping pins to mark off items for a punch list. Using the Reconstruct platform is really easy. You walk the site taking video with a 360 camera or even a smartphone. And then using our patented technology, Reconstruct will take those unintelligent videos and make them smart by stitching them together. The process is fast and it can be done right on site. Steve will walk you through what this looked like at the Denver site.
Right, so it is a very straightforward process, but there are some tips and tricks that we've learned over time. This is the third mega capture that we had done. And so one of the things you will need to do is place QR code targets throughout the building. They don't need to be measured placements, but they're there so that all of the imagery can be stitched together by the AI or the algorithms in the cloud. Then you basically are walking the site in sections and making sure that you're overlapping the sections that you have taken video of. And then when we're done with this capture of many, many different captures throughout this large building, we upload that video to the Reconstruct Cloud, and then that automatically processes, aligns the different scans, and then we can have access to a point cloud that is accurate and usable. And once the point cloud is in Reconstruct, what we can then do is bring in any drawings or models that may have been available to us to validate whether a drawing is accurate or not, and then actually be able to see all in one place, in one view. This is a view of the reality capture, Revit model, and 2D floor plans all in one place. So it's a very a quick and easy way to tell what's really there and what's documented and what the differences may be, so that you can solve those problems, update your documentation, and then start off with a good set of documents for repair alteration.
So this is the reality map that Reconstruct provides once that video is processed in our platform. It's overlaid on top of the 2D floor plan. And when you're in the platform, users can easily toggle between either the 2D floor plan or the 3D reality map. So I have a video demo that I'd like to share with you of what the Denver GSA building really looks like within the Reconstruct platform. So remember, before using Reconstruct, there were only frankendrawings of the property. And now we're starting off with a full 2D floor plan. So the blue lines you see are the path that was walked while capturing the video. And then we stitch those videos together to create the 3D reality map. The first section of the video that we're going to zoom into is an office space. And we can actually zoom in on these images and see full detail down to furniture or equipment. The second portion here is a warehouse area of the facility. And this is where we can see how the measurability feature really comes into play. With Reconstruct, you can measure both height and width down to that sub-inch level of accuracy. And then we can move around within the facility to look at any different viewpoint, look where different beams are placed, and we can even measure the footprint area, like this particular landing pad. Reconstruct can be used outside in the exact same way. You can drill into the images, and we can look at things like the parking lot to check for potholes or defects. And we still have the same level of measurability. So we'll be able to measure things like roof clearance or the length of maybe this kind of unusually curved roof on the Denver GSA building. Captures can be completed using drones for outdoor larger areas, but no matter how the video is captured, whether you're using the platform inside or outside, Reconstruct will allow its customers to see what's there versus what should be there. So going back to the Denver project, A simple $400 off-the-shelf camera was used to complete the video capture in lieu of significantly more expensive laser scanning hardware. Reconstruct then converted those images to an accurate and measurable reality model. Using Reconstruct versus laser scanning brought the price down significantly from $1.25 per square foot to 15 cents per square foot with comparable levels of detail. And it was significantly faster. The technicians were able to capture more than 200,000 square feet per day and completed the whole facility within less than a week. That's significantly less time than it would have taken to move the scanning tripods around the site. Overall, Reconstruct provided the cost-effective and time-sensitive solution that Steve's team was looking for.
Yes, it looks like we have a couple that have come through already. Right here, it says the first question is, so it sounds like the project went well. But were there any noteworthy learning moments?
Yeah, and I'm going to pass this over to Jason Reese, who headed up the actual project delivery. Jason, do you want to answer that question?
Yeah, certainly. I think one of the key things to understand is that this is a little bit different than laser scanning. When you're taking video and converting it to point cloud using photogrammetry, it's really important to make sure that you aren't going too far, so to speak. So capturing too much area at one time can create some issues for the reconstruction piece of it, which looks for like similar photos and overlap, and being able to properly plan how much area you're going to capture in one walk or one video, so to speak, is really important so that you don't, so the system and the software can process it correctly. And then you can use those. Then what we did is we use those smaller captures and combine them together in order to create a larger, more comprehensive point cloud for 100,000 square foot. We didn't walk and try and capture 100,000 square foot at a time, even though we might have been able to do that in a single walk. That's kind of a big one. Another one is that a good lesson learned for us was that when we're on site and doing a capture, it's really important to try and upload and process the videos the same day that you've captured them, and allow for the system to do the reconstruction so that the next morning or whatever, you're able to look at the capture and see, all right, did it capture accurately, or did the system have some challenges with certain areas? Corridors tend to be challenging for the system. So it's being able to do that quality control while you're on site, and the speed at which Reconstruct is able to register and process those point clouds allows for that immediate feedback for how good of a scan that you received. So that's another big part of it. And I think a third point is the speed to getting the scan to the modelers is so that they can pull it into Revit or whatever software you're using, is really important that you take it into the Revit model and do some alignment over there in the modeling product, and be sure that you have an alignment that you want your modelers to use. And the folks that did the capture on site really need to be responsible for that piece of it, because they're the ones that were immersed in the building for several days. So I'd say that's the three key big ones. One oops moment for us on this project was that the QR codes that we printed out, we actually messed those up quite significantly. But we were able to still use them, but in a not quite as effective way. But they were still very helpful, even though they weren't auto registering for us because of the mistake we made in the printing. So be sure that when you're printing out your QR codes, you want to make sure you have a lot of them, but make sure they're printed correctly.
Thanks, Jason. Great. We have two questions that came through regarding point clouds, one in the chat and one in the Q&A. One is, how long did it take to process the point cloud? And then the other question is, regarding point clouds as well, is Reconstruct able to remove the noise from the point clouds? So who would like to take on the question regarding point clouds?
I could take that as well. The first question was, how long does it take to process the videos into point clouds, correct?
Right.
So it really depends on how, it's a video, and you're not taking straight video, you're taking time-lapse video. So it's taking a picture once every second, and it's creating a time-lapse video. The time to process that depends on how many images are associated with the video. So a video walk of, where the actual time is, 2 minutes, might only be something like 800 images. And that process is relatively fast. That might be done within, an hour or two, something like that. Whereas a larger capture, say you get towards 3,000 images, which is closer to the limit of what you can process at one point at a time, that might take 7-8 hours, depending on the software and how easily you can recognize your path in different images. But the short answer is that once you upload it, the system pretty much takes care of it, and you have a registered point cloud as soon as it's done that you can use for quality control and validation. Second question was what? Remind me?
This second question was regarding removing noise from point clouds.
Yes, removing noise. So Reconstruct is a platform for capture. It doesn't really provide point cloud editing capacity. What we do is we export out the point cloud that Reconstruct generates, and we pull it into Autodesk Recap solution, and we clean up any noise that we need to there. Although generally speaking, we don't do that because what we're using this type of level of detail in a point cloud for is to validate what's there. We're not as concerned with producing a very, very highly accurate to the 1/8 of an inch point cloud. We're to see, all right, is this wall 1 foot, is this wall 10 foot and a quarter, or is it 10 foot and an inch and a quarter? We don't care so much. We care, is there actually a wall there or not? Has someone added a wall in the past 10, 12, 20 years, reconfigured the space, and then using that information to generate it? So we're not so concerned with noise in the point cloud, but there is a good bit of it because you are reproducing from a photograph. So if you have a bunch of pipes in the ceiling, the photograph sees shadows and various other elements, and it's not a laser scanner where it's pinging off of a specific object. It's trying to recreate it from a photograph. So there's more noise than you expect from a laser scanning process, but again, that's not something that really affects our process at all.
Great, thank you so much, Jason. One other question I see here regarding BIM models. How long does it take after the capture to create the BIM model?
So again, that's going to depend obviously on the size of the building. This is 700,000 square foot building here. We were contracted to create an LOD 200 architectural model. So again, the level of detail that the client is looking for, again, has an impact. But for this particular project, it took about 6 weeks of total modeling time to create that first draft of the model that we then go through all our QC processes, which takes a good bit more time going back and forth, validating against existing condition documentation, all the photographs we take, the point clouds, and any other sources of information we have to make sure that we have a good model. But the initial usable complete model was about 6 weeks for the architectural elements. We also had MEP in this particular deliverable, but it was really just an LOD 100, and don't laugh when I say that. I know how silly that sounds, but really just from a client's request of saying, hey, if you see MEP systems, we'd like to get an idea of what's there, whatever you can give us. And so that's what we also provide. And that took another bit more time as well, because you're obviously using all these different sources to try and recreate ductwork that you may or may not see, pipe work that disappears in between walls, pops out in another space. It takes a bit more time to get that MEP work done. But for the main part of this contract, 6 weeks was about the core modeling time.
Great. I think time for one more question. We have one about geolocating. Are you able to geolocate the Reconstruct data?
If you're talking about a very specific geolocation of the to correlate it towards a survey point or something like that, we don't, but you certainly can. Those yellow tags you have, if you're acquainted with laser scanning, the targets and everything, how the same process you would use to align those targets to a known geographic point, you would use for the same methodology for placing those individual targets as well. They have, those targets aren't just a QR code. There's actually a survey point on them in the upper left-hand corner. The large format, they're not actually QR codes. I forget the exact terminology, but those are really just for the photo software to recognize that, hey, this is a point here, and when you see this, place a survey point in a certain location on the paper. So yes, you can. If you're trying to use that to get down to a quarter of an inch accuracy, probably not really what you want to, probably not a system that you're trying to do. So if you're trying to do geolocation, it might not be the only system that you want to use. You might want to bring in traditional laser scanning to set up control for a project, especially in corridors and that type of thing. But yeah, absolutely. Reconstruct has, you can actually tag the different tags and points. You can bring in your files for geographic points and align them that way as well. So the system does provide for that. You could do it, although for our purposes, that wasn't something we're concerned with.
Great. I think that is all of the questions we have right now. But yes, thank you all for joining on this webinar.